This instructional video will demonstrate how to use the method of initial rates to answer basic questions about reactions, such as what is the rate law, what is the rate constant, and what is the half-life of the reaction. The difference between this video and the previous video on just the method of initial rates is that we take it beyond that initial rate to actually get into a discussion of time-dependent concentrations. So, by the method of initial rates, we want to compare our reactions. And so if we look at trial 1 versus trial 2, what we notice is that there is a doubling in the concentration. So 2 times the concentration gives us 2 times the rate. And if we compare 1 and 3, we see a similar kind of relationship in that 5 times the concentration results in a change of 5 times the rate. And because in both of these cases that's 1 to 1, we can reach the conclusion that we have the rate is equal to the rate constant times the concentration of sodium phosphate to the first power. So this is a first order reaction. So that shows that we have determined the form of the rate law. To find the value for the rate constant, we have to solve this equation, which is fairly straightforward. We write that the rate constant is going to be the rate divided by that concentration. So we can pick any of the trials. I'll take trial number 3. So if the rate is 250 and we've suppressed the units, but the units for the rate is concentration per minute. And so we just have concentration here, 2.0 molar. And so this gives us a value of our rate constant as being equal to 125. And the units are 1 over minutes. So this gives us the value for the rate constant. Now, because this is a first order reaction, it's straightforward to write out the answer to this third part. The natural log of our concentration at time t will be equal to negative kT. So we have 125 times time, and that's all in minutes. And this is plus the natural log of our initial concentration at time 0. So because this is the expression, we already know that for a first order reaction, the time it takes for this concentration to be exactly 1/2 of the initial is only a function of the actual rate constant. And so we have ln of 1/2 divided by negative of the rate constant itself. And since this is 1 over minutes and it's in the denominator, our units will work out to be minutes. And so the actual answer we get is 5.5 times 10 to the minus 3 minutes. So for a first order reaction, we find that when we look for the half-life, that value turns out to be independent of the initial concentration. So this answers all of our questions. We have the form of the rate law. We have the value of the rate constant. And we have the half-life of the reaction, independent of which trial we use.